And if we could just get started, I want to give a quick overview of our presentation here. I'll cover the introduction and the StreetLight data extraction, as well as some of the forecasting applications, and then Luana will close us out with some of the traffic applications that we've used here at Sain. So the big question I think that everyone has on the call is why StreetLight data? There's a number of reasons that we have started to use StreetLight more and more. Starting with the practical matter of we want to keep projects moving forward. We have a lot of traffic impact studies, project planning studies that were on hold because we're waiting on traffic manual turning movement counts to come in. When I discussed our situation with Adam and some others at StreetLight, we determined that we could use this as a surrogate for some of our turning movement counts on some of our traffic impact studies, and that's a practical reason why we selected it. Some of the other reasons why we use StreetLight data from the forecasting perspective is the ability to be able to bridge the gaps between travel demand model estimation and the lack of having a household survey. I think if there's a number of folks from DOTs and NPOs on the call, y'all are aware of the costs involved in household survey, and using the StreetLight data as kind of a surrogate for one of those extensive efforts is definitely another benefit that I've seen with the application. And then as a person that does a lot of project planning, forecasting over the years for kind of high profile NEPA-related studies, one of the biggest issues I've seen over the years is inconsistent data sets, relying on, there could be 50 intersections and you're looking at turning movement counts that were collected in 30 or 35 different time periods over a course of a couple of years. And we tend to rely on those as our base conditions data set. The limitations I've observed over the years with those approaches is, for example, if you have a saturated corridor and another parallel facility, in the case of Washington, D.C., I-270 is one that comes to mind, and then there's a parallel corridor that's also very consistent. If there's an incident on the parallel corridor while you were doing that manual count, you'll never pick that up in your data set until much later in the process where you're actually developing forecasts and defending them. And you don't want to find out about limitations in your data while you're defending travel forecasts towards the end of a project. So for me, that's the ability to be able to look at multiple years of data over multiple time periods, and to, even if it means using StreetLight as a quality check of some of the turning movement counts that we may have received or collected for the project planning study, I think the benefit is enormous in terms of getting a valid data set that you basically use for your seed in terms of developing your forecast. So those are the three big reasons why we've kind of migrated to using StreetLight data. And then some of our experience, just a quick overview. We've used StreetLight on a couple of studies for trace crossings. They're related. The OD study was essentially done to inform the travel model update. We've also used StreetLight for turning movement counts on the Prattville Comprehensive Plan, as well as the Grant Road corridor before and after analysis, and the Ina Road and Thornydale Road signal timings in Marana, Arizona. And I'd like to talk a little bit about the StreetLight data extraction for both turning movement counts and forecasting. I won't belabor the turning movement counts, as Becca's covered the basics of how to code and extract that data. Just a quick overview, as Becca mentioned, you draw, we skipped this, I'm sorry. So on the forecasting side, you would mirror the process that Becca presented in terms of drawing the zones for your origins and your destinations. The difference on the forecasting side is, well, specifically because we're looking at transportation analysis zones and census tracts a lot of times on the forecasting efforts, we're able to read in those shape files directly in the StreetLight seamlessly, and essentially use that as our geographic base for zone origins and destinations. That allows you to look at a much larger region than just, an intersection with an origin and 3 destinations. And similar to the turning movement counts, you'll process the data on StreetLight, and then to me, the most important step in all of it is your data review and quality control. And I say that for any data set that you would receive or obtain out in the field. This covers some of the forecasting applications we've used StreetLight for, starting with the pass-through analysis. So for trace crossings, we wanted to take a look at how the actual trip behaviors compare to the travel model behavior. So the beautiful thing about StreetLight is we were able to do an apples-to-apples comparison because we're able to look at the total magnitude of trips, the trip purpose, which most travel demand models are estimated in that fashion where it's estimated by trip purpose, and then also most travel models also includes income brackets for the various trip purposes, and StreetLight was able to match that on an apple-to-apple comparison basis, and we were able to basically compare the StreetLight actual results to the base condition RPC, which is the Birmingham NPO, regional travel demand model trip tables, as well as some of the external stations, just to get an idea if we had differences or discrepancies between people leaving the region and going to some external places. Next slide, please. The non-pass-through analysis, I guess just to specify a little bit, pass-through is basically the trips are going through the zone. Non-pass-through, the trips are either originating in that zone or that zone is a destination for the trips. In the case of the trace crossing study, we wanted to look at the Hoover Met Stadium specifically and the SEC baseball tournament that occurred back in 2018. Our client had a lot of anecdotal kind of evidence related to behavior at these tournaments, but wanted to see, what the trip patterns look like on that Saturday versus a typical Saturday or weekday, which we were able to do with StreetLight, as well as look at the home locations of visitors to the stadium, which provided them some unique insight because they suspected that a lot of people were coming from all over the country, but we were able to just graphically illustrate kind of the hot spots where they were coming from, and they were all the way from Arizona, as far away as Arizona, coming to the tournament in Hoover. And ultimately, one of my first points I was making with regards to travel forecasting applications and how we can use this data to either supplement or as a surrogate for household surveys. This is just a few of the things that we looked at with the RPC travel demand model. There's any number of other things you could look at, but specifically, you want to be able to look at trip generation and distribution, and StreetLight allows us to do that. Can be also used to evaluate and or update mode choice models, as well as identify some basic demographic and network coding errors. Very useful in that regard, and also the updating of friction factors for external trips is one of the things we did for the RPC model. And this was the ultimate outcome. It's a little grainy, but this map illustrates the differences we calculated between StreetLight and the actual Birmingham RPC travel demand model in terms of the trips. And this one is for home-based work specifically. And then what you see in the callouts are just some of the recommendations that we developed for the model improvements as a direct function of what we observed between StreetLight compared to the travel demand model trip tables. And with that, I will conclude and pass it on to Luana to talk some about the traffic applications.
Thank you, Paul. So I'm just gonna wrap up our presentation. Paul mentioned a few applications of our StreetLight data into planning. So I'm just gonna go over a few examples in traffic engineering. And if you think about it as a traffic engineer, there are a few things that we need data, or everything we need data collected for. So if you're working a traffic impact study or a signal timing study, you need turn movement counts, And why would we decide to use StreetLight data instead of manual counts? So if you think about it, your new development for which you're working on this traffic impact study, or your new signal or your existing signal, they're not going to be there just at a specific day and a specific time. So when you go in the field and you collect manual counts for a specific date and time, not necessarily that represents what your traffic conditions are on average. So when you use StreetLight data, you have a more representative data because it has an average of an entire year, for example. So you can use that, and it better serves your purpose and the purpose of your project. So that's one of the advantages as a traffic engineer for using StreetLight data. Another thing, if you think about safety studies, if you look at the Highway Safety Manual, all methodologies are going to require that you use a lot of years of ADT before and after implementing a countermeasure, for example. And it's at least 3 years before, 3 years after. After you implement that countermeasure, how are you going to go back in time and actually collect that data? If you don't have that count available, usually what we do is just assume that ADT doesn't change, or we try to estimate some growth based on growth rates or something. But it really helps when you have a platform like StreetLight that allows you to go back and look at 2016, 2017 ADT for a specific location. Another thing that we usually need good data for is speed studies, travel time studies. If you have a corridor study and you have this long road segment on this specific road, you make several improvements to it, and you want to know if your traffic flow conditions are actually better. How can you tell if your speed increased, if your travel time decreased after improvements? Because for the same reason, you can't just go back in time and try to collect all that data. So it's good to have a platform that lets us use the same methodology and compare before and after data for several performance measures. And the last thing I want to mention is a really good thing of StreetLight data is that it's very easy for you to just get weekday data, weekend data, off-peak data, all things that usually we don't think about when we're working on a project. If you have a project at a vacation town or at the beach, your peak hours are not going to be the typical 7 a.m. to 9 a.m. or 4 to 5 p.m. on a 4 to 6 p.m. on a weekday. So you can get weekend data, you can get Friday data, you can get everything you need easily at the StreetLight platform. Becca already mentioned how we can collect TMC data from StreetLight. So I'm just gonna talk about every methodology has a few limitations, and I just want to illustrate a few examples of a few things that we saw that for each project you have to consider which is the best alternative for you to use counts for that specific situation. So this first example is from a two corridor signal timing coordination that we worked on. And we had more than 10 intersections, but I'm just going to show here 2 intersections for which I found some limitations on the StreetLight data. And just, it's just for you to be aware that the data is great, but for each project, you have to actually look at the specific conditions and see if it's reasonable to use and if it's good for your specific project. So here, I want you to focus on the northbound through movements. And for Thorndale Road, if you look at it, the number of through vehicles, when you compare StreetLight data, which is the last table, to camera data, it's closer to what the manual counts were, which is the first table there. So it had 800 something vehicles going through in the manual count, and StreetLight gives you about 1,000 vehicles. And then when you looked at a camera methodology, it was 300. So overall, the volumes from StreetLight data were good, even at this intersection where we had limitations. But one problem that we saw was, if you look at the westbound approach, the total number of vehicles overall makes sense when you compare to the manual counts, but sometimes the volume distribution was a little off. For example, we had about 15% vehicles westbound right, but StreetLight data showed us 37%. And the reason for that was because this was a new intersection configuration. It was a modified corridor configuration as well. So sometimes if you don't have as many data points to validate your data, that can be some limitation of the methodology. And another thing that I want to mention is we as traffic engineers usually shoot for a peak hour, but sometimes your peak is actually 15 minutes. For example, if you work on a school project or if you work on an industrial development, that peak is going to be 15 to 30 minutes. So with StreetLight with StreetLight, the smallest data range that we can get increment is 1 hour. So we don't have that TMC manual count every 15 minutes. So sometimes that can be a limitation depending on your project. So as I mentioned before, it's important to always look at your project characteristics, and then based on that, you decide which platform you're going to use for your data collection. So here, just to illustrate that same corridor signal timing study that we worked on, what I wanted to focus here is where you have that red location there, that intersection, and then the Interstate I-10 ramps. So I tried to compare how many vehicles left the Star Commerce Way intersection and got to the I-10 ramps. So I compared two things, cameras, and I compared StreetLight data, just to validate the data and see if that would be reasonable to use for that specific intersection. So when you look at the numbers and the difference, so what I want to show here is, so the difference leaving the Star Commerce Way intersection and getting to the ramps, when we use StreetLight data, that eastbound difference was about 600 vehicles in the morning. And then when we use the cameras was about 35. And if you think about what we have in between, that's a fast food restaurant and a small high school, you're not going to expect 600 vehicles difference in that short segment. So in this case, we thought that there was some limitation to StreetLight data. And one of the things that we noticed too is when you have low volume intersections for which Star Commerce Way was a very low volume approach, sometimes StreetLight data has limitations also due to us not having yet as many data points to validate that. So two things that we noticed was if you have a new road, a new intersection configuration, or if you have low volume approaches, it's good to check the data before with some existing counts or something, or based on your judgment, to see if those are actually reasonable to be used because of the data validation issues. I want to finalize these examples. This is a corridor before after analysis study. So this was a 4-lane road that was widened from 4 to 6 lanes. And also some indirect left turn intersections were added to this segment. And most improvements were from segment 4 to segment 7. So you finalize your project and you want to show everybody how your traffic flow conditions are better, right? But how can you compare your speed and your travel times to how it was before if you don't know how it was before and you can't go back in time and collect that data? So we were lucky to have the opportunity to have StreetLight data available, and we could compare with the same methodology, same platform, how travel time and speed conditions changed. So if you look from segment 4 to 7, and this is the AM peak, you can see a decrease in travel time, and at the same time, you can see an increase in speeds, which is what you expected with that improvement. And then in the PM is the same thing. So this is just an illustration of how you can go to the public, you can actually show this visualization and tell people not only we're telling you that traffic conditions are better, we have some metrics that can help explain that. So for what we've seen so far, StreetLight data, of course now during COVID, we realize more and more how relevant that can be to our studies because we could collect traffic movement counts before March, where all the closures happen. But also moving forward, we think that there is a big chance we are going to keep using this for several projects that we have for all the reasons that Paul mentioned, that I mentioned. So it's a very good platform, and jurisdictions and consultants, everybody will benefit from using it.